started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we'll cover the basics of Python strings, including how to create and manipulate text. The goal is to learn the essential techniques to handle text data efficiently in your Python code. We'll start out with some basics and definitions. Strings are immutable sequences of characters that store text. These characters can include letters, digits, or symbols. And by immutable here, we mean that strings cannot be modified directly after they've been created. However, we can create copies of strings that have our desired modifications in those new strings. String literals are string values that are specified by you, the programmer, in your source code. They're always surrounded by quotation marks to make them distinct from other code, variable names, functions, and so on. These quotations can be either double or single quotes. Let's take a look at a few examples. Dan here in double quotes is a string literal. Its value is stored in a string object, which is assigned to the variable name. Here we see an example of a string literal using single quotes, which contains the text 3D printing. There's no difference between double and single quotes, except in one minor case that we'll be seeing soon. The PEP 8 style guide states that either form is acceptable, but you should pick one and stick to it. Avoid switching back and forth between the two styles without reason. Next, we have a double-quoted string literal that contains a phone number. The last example is a bit more interesting, as there's actually two strings here. The first is the string literal that is passed to the input function. This is the text that's displayed to the user to prompt them to provide input. The second string is not a literal, but a value returned by the input function, which is the value input by the user that's eventually going to be assigned to the address variable here. One important feature of strings are escape sequences. Escape sequences are used to represent special characters in our string literals that have special meaning or would typically be illegal in our strings. Escape sequences start with the escape character, which is a backslash followed by one or more characters that define the escape sequence. So here we have a table of some of the most common escape sequences that you're going to encounter, but there are more. Single quote and double quote escape characters allow us to include a quote character in our strings without Python interpreting them as the end or the start of a string, which would likely cause an error. Similarly, the backslash sequence allows us to include a literal backslash character in our strings without Python thinking that we're trying to escape something. The new line and tab sequences can be helpful for formatting our output and adding extra line breaks or tabs in our strings. A common issue you might encounter when creating string literals is dealing with quotes that should be in the text of your string. This issue here is that Python might interpret these as the end of the string and cause an error. In this example, if we attempt to assign the string Charlotte's Web to the variable book title, we could get an error as the apostrophe in Charlotte's Web would be mistaken for the ending of a string. This would cause an error similar to the one on the screen right now that states that the string is unterminated. There's a few approaches we could take to correcting this. The first would be using an escape character to escape that apostrophe. The backslash before the quote escapes it, meaning that Python does not see it as the end of the string, and this would work fine. The other approach we could take would be to use a double-quoted string literal. And this is that minor difference I mentioned before, between double and single-quoted strings. Double-quoted strings can contain single-quoted characters without escaping them just fine. And the opposite's also true. Single-quoted strings can contain double-quoted string characters without escaping them as well. So we have two different approaches we could use in this case to encode Charlotte's Web and keep that apostrophe. We could either escape the apostrophe using the escape character, or we could use a double-quoted string. Another thing we can use these escape sequences for is for formatting our output a little bit. Let's take a look at an example now of how we can accomplish this. So in this example, the end escape sequence adds a line break. This means that when we output these strings, every time there's a /n, a new line is going to be output in the console. The other escape sequence that we can see here is the use of the /t sequence, which adds a tab character. Let's take a look at what the output of this program would be when we run it. And here we can see that output. Note that we have some extra line breaks, even though that one line is printed with just one print statement. The whole hello, welcome to Python 1026, this is an example of some line breaks. We can see that in the console, it is printing on multiple lines. Every time we encounter one of those /n's, the line break sequence, it starts a new line in the console. We can also see that the tab characters are working, and that we are getting extra space, for example, between name and grade, or a student name and their grade percentage. Now we can't really see these line break characters because they are invisible characters, but if we could add them to our program, or our output rather, they would look something like this. Now you might note that there are a few extra line breaks here than what we specified in our strings. The reason for that is the print function includes a line break at the end by default. So every time you call print by default, it's going to add a line break onto the end of your output. So another thing we need to cover is string length. And in some cases, we might need to find the number of characters in a string. We can accomplish this using the length function. The length function works on a collection and sequence types and returns the length of that value. In most cases, this is the number of elements in that collection, but for strings, it's equal to the number of characters, including any spaces or special symbols. Let's take a look at an example. Here we have a string with the text hello world with an exclamation mark at the end. The output of this program would be 12, as the string contains 12 characters, including the space and exclamation mark. The second example is a special case of an empty string. This string contains no characters between the double quote marks. The length of this string is simply 0, as it contains no characters. And one of the most important concepts to understand about strings is indexing. We can think of strings as a continuous set of boxes, one after another, that each stores a single character. Each of these boxes is given a unique number to identify it, starting at 0 and going up by 1 for each character. We call this number the string's index. In this example on screen now, for the string hello world, we can see that each character gets its own numbered box, including the space character. And we can use that index to access a specific character or value in the string. For example, index 6 would be a capital W, and index 0 would be the capital H. In Python, we can access a character at a given index by using the brackets operator after a variable name, and these would be the square brackets. Let's take a look now at an example. So we still have the string hello world, and this string is assigned to the variable s. The first print line attempts to output the characters in the string at index 0. In this case, the character at index 0 is h, so that's what's going to be output. The next print line is the same idea, but accesses the character at index 6. In this case, the character at index 6 is capital W, so that's what's going to be output to the console. The next line prints the character at index 10, which in this case is the last character in the string, a lowercase d. Using string indexing, we can easily retrieve any character in a string. I should also note that string indexing also works backwards. If you use a negative index, it'll start at the end of the string and move to the start of the string, as we can see here. For example, if we use the index -1, it would retrieve the last character in the string. In this case, that would be the lowercase d again. If we used -3, we could get the third last letter, a lowercase r here. If we used -10, we would get the 10th last letter, which is a lowercase e in this example. One thing you have to watch out for, though, when you're working with indexes and strings, is that you have to specify an index that is in the bounds of the string. If you go out of the bounds of the string, you're going to get an error. Here we see some examples that would result in an error. This line attempts to retrieve the character at index 11. However, this string's indexes only go up to 10. This means we would get an error that looks something like this if we attempted this. You can see the error is an index error, and it's letting us know that the index is out of range, meaning that we went outside the bounds of the string. The next example would also produce an error, as negative index in this case only goes up to -11, and -12 would be out of the bounds of this string. The last line is also invalid. But this time, the issue is not the index. Recall that strings are immutable, meaning that we can't modify them after they are created. This line is attempting to modify the value of the character at index 0, which is not allowed and would result in an error. We can make copies of the string, but we can't edit them. Time for another example. The program currently on screen attempts to find the first and last initial of the user based on the first and last name they input. We'll also try to find the last letter of their first name and the third letter of their last name. Let's give it a try. Okay, here we are in PyCharm and we have the example loaded up. Now this time we're going to try something a little bit different. Rather than just running it, we're going to try running it in debug mode so we can get an idea of what's going on. Debug mode allows us to run a program one line at a time, even if that line's not blocking. And the way this works is first we have to set a breakpoint. So a breakpoint is where the code is going to stop and wait for us to tell it to go to the next line. You can do that by clicking on the line you want to set a breakpoint on. So in this case, I'm going to set a breakpoint right here on this first real line. And instead of hitting run, we're going to hit debug. Okay, what we're currently looking at is the debugging interface. So because we clicked on debug rather than run, instead of the console, it opened up the debugging interface. And this window will show us any variables we've declared so far, as well as their value. And because we put a breakpoint on line 5 here, it stopped right at first name before it's called the input function. If we want to see what the console looks like, we can click on console, but nothing's been output yet because this function hasn't been called. And this is great because it will let us to run our program one line at a time. We can run this line by clicking F8 or this button here, step over. We can see the input function has now been called, and I can input my first name. And if we look back over at threads and variables, we can now see that there's a variable called first name equal to Daniel, which is the value I input. The code has gone to the next line and paused, waiting for us to click on this button before it actually calls the input function. So if we click this button again, it now runs that input function, and we could put in our last name. In this case, I would put in my last name, which is Servos. And if we take a look again at the threads and variables, we can see that we now have a last name variable, and it is equal to Servos. And we have paused right here on line 8, where it is going to output our initials, but it hasn't done that yet. So when we want to run that line, we click step over again, and we can see that it output your initials are DS. Note that we got an extra line break here. The reason why is this character here, the /n, that added an extra line break. And then it said your initials are the value of first name at index 0 and the value of last name at index 0. So if we look at our two values, first name index 0 would be the D, and last name index 0 would be the S. So we got DS. Remember that strings always start at a 0 index, unless you're going backwards. So we'll click step over again. We get to the next line, which is the last letter of your first name is L. The way this worked is indexing it at -1, so that's going to be the last character in the string. So if we look at the string first name, the last character is a lowercase l, so that is correct. We'll do step over again to get the last line. And it says the third letter of your last name is R, and that is correct. The variables are gone now because the program's over, but you can see that the third letter of my last name is an R. So debugging allows us to run through our program line by line, and it lets us sort of explore what variables are doing, how they're changing, and things like that. So it can be very useful if there's a problem in your program, but normally it won't block like that. So we'll run this program again. And one thing I want to show you is there is a little bit of a problem with this programming, something that we overlooked that will cause an error for certain inputs. So the first name is fine, I'll put Daniel again. But what if our last name was less than 3 characters? What if there was no third letter of our last name? Like maybe my last name is just SR. And we could see what happens here is it starts running and we do get some output, but we also get this error message, and that last print doesn't actually happen. The reason why, we can see the index error, string index is out of range, and it's pointing right to this line here. The reason why is this is accessing the third character in our last name, but we only inputted a string that had 2 characters. So when we take input from users, we have to be very careful because the user could put invalid input or input that we didn't expect. Later on in the course, we'll show you how to deal with errors like this, but for now, we're just going to have to assume that the user inputs the correct input. Let's switch back to the slides. And we're back. Let's move on now to string operators and methods. So just like we have operations and functions for arithmetic, there's also a number of built-in operations and methods for strings that will be extremely useful for us when we're dealing with text. In a previous video, we covered some of the basic arithmetic operations, such as addition and multiplication. However, these operations have a special meaning when used on strings. The plus sign operation for strings is the concatenation operator rather than addition. When used on two strings, the result is a new copy of the string that contains both strings added together. For example, if we concatenated strings cat and dog, the result would be a new string containing the text cat dog. If we concatenated the value of the variable s, and let's say s is equal to pepperoni in this example, and we concatenated that with the string pizza, we would get a new string with the text pepperoni pizza. The multiplication operator for strings also has a different meaning. In the case of strings, it means repetition. A string multiplied by an integer value will result in a new string with that string being repeated a number of times equal to the integer value. It sounds a little bit complicated, but all it means is we're just going to repeat the string n times, where n is some integer value. So in this example, the string contains the characters h, a, and a space, and we're timesing that by 5 to create a new string with the text h, a, space repeated 5 times, or ha 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 ha. This also works for strings stored in variables, such as with the pepperoni example shown here. So if s stores the text pepperoni, timesing that by 3, we would get pepperoni, pepperoni, pepperoni. Lastly, the modulus operator, when used on strings, also has a special meaning, and that meaning has nothing to do with remainder. Rather, it's the string formatting operator. And we're going to cover this more in a future video, but if you're interested, you can read about it in your textbook now, and it does have to do with formatting the string with different values. In addition to string operators, there are also a number of very helpful string methods. But what are methods? I've mentioned that a few times, but I haven't really elaborated. Well, as I mentioned in a previous video, objects can have methods associated with them. Methods are collections of programming instructions that carry out some specific task on that object. They define behaviors an object performs as well as actions we can perform on that object. They're very similar to functions, but methods can only be applied to an object of a specific type. For example, string methods are only available for objects of the string type and not other types such as integers. Let's take a quick look at an example. Here we have a string with the text, all lowercase, stored in it. The second line calls the upper method on the string s in this case, which creates a new string with all the letters converted to uppercase. The variable s is then assigned the value of this new all uppercase string, and the old string is eventually lost to the garbage collector. The result after this print line is run is outputting the string with all uppercase letters, so it still says all lowercase, but all those letters are going to be in uppercase this time. There are many other string methods, and I have some of the most commonly used methods listed here. The lower and upper methods create a copy of the string with all the characters in upper or lowercase, as we just saw in that last example. The replace method takes two string parameters, an old value and a new value. What this method does is it takes a look at string s, and wherever it finds an old value, it's going to replace that with the new value and return a new string with those replacements. This might be a bit more clear looking at an example. So here we have the string s, which has the text hello world. And we are saying that new value is going to be hello. That means it's going to look in the string s for any occurrences of hello, and it's going to replace them with the old value, in this case bye. Remember, this doesn't edit the existing string, rather it creates a new string with these replacements. So the return would be bye world. The count method returns the number of times the string value occurs in the string s. In the example shown here, we are counting the number of L characters in the string s. So if s is equal to hello world, then the count would be 3, as there are 3 L's in hello world. And I should note that this isn't limited to characters. We can count the occurrences of any substring. That would be any string that occurs in another string. The strip method makes a copy of the string with any leading or trailing spaces removed. This can be very useful when we're cleaning up user input. If you think your user might accidentally put in a few extra spaces before a value or at the end of the value. The last method shown here is the format method, and this is another tool for string formatting that we'll be looking at in a future video. But it is detailed in your textbook if you're interested right now, and just like that string formatting operator, it helps with formatting strings given certain values. Time for a more complex example. Using just what we've covered so far, we can make a somewhat interesting program that censors tweets or any kind of text, really. In this program we have on the screen right now, we input a tweet from a user or any text, and it strips off any leading or trailing spaces. Then it converts that text to lowercase, counts the number of words in the tweet that we consider to be bad words, and then censors those bad words before outputting the result. Let's switch over to PyCharm now and take a closer look. Okay, we have the program loaded up in PyCharm, and this is one of the longer programs we've seen so far. And we can see this is going to try to censor a few bad words. In this case, they're just bad, unhappy, and sad. It's going to both count them as well as replace them with asterisks. And because we want to see how this works, we're going to run it in debug mode, and I'm going to set a breakpoint right here on line 7. Okay, we have our debugging interface up. And I'm going to move over to the console. We don't see anything going on yet because we're still blocked here, and we have to step into that to run the input. Just asking for our tweet text, lots of spaces, and in the end. And we have a tweet that says, I'm sad, I had a bad, unhappy day, so sad. And if we look at threads and variables, we can see that it's been stored in tweet, and we can see those spaces I typed in are at the beginning and end of this string. So the next line that's going to run is tweet equals tweet.strip. This is going to call the strip method on tweet. It's going to remove these spaces at the beginning and end. It's going to create a new string, and then we're going to rebind the tweet variable to be pointing at that new string object. Just remember, we can't modify strings. We're just creating a new one and storing it back where tweet was. So let's step over, and we can see the value of tweet has changed, and it's now pointing at a string that no longer has spaces at the beginning or end. The next line here is going to convert it to lowercase using the lower method. So same idea, this is going to return a new string, and it's going to assign that to tweet. So it's not modifying the string, it's making a new copy with all lowercase, and then putting that new copy in tweet. So when we run that, we can see that the I is changed to a lowercase I, as has the S in so. So the next part of the code is going to be counting the bad words, which are bad, unhappy, and sad. Right now we're starting off with bad words equals 0. We can see when we run that, we get bad words equals 0 in here. That means we've assigned a new variable called bad words and assigned it an integer value of 0 to get us started. The idea here is we're going to do a count for bad, count for unhappy, and a count for sad, and we're always adding those to our bad words variable. So the first one is going to count all the values of bad in our string and add that to bad words. So let's try that. So now we get 4. So there is 4 bads here, 1, 2, 3, 4. So we're at 4, but now we're going to count unhappy and then update the value of bad words. So we'll run that. And now we can see it's updated to 5 because there's only one occurrence of unhappy. The last one is going to be counting sad. So there should be 2 occurrences of sad. Let's see if it adds those. And it does. So from 5, we get to 7 because we added 2 for each sad. Now we're at the part where we're censoring words. And this is going to make use of the replace method. So remember, replace looks for the old value and replaces it with the new value, but it creates a new copy of the string. So when we run this, we can see that it has looked for all the instances of bad in our string and replaced them with 3 asterisks. So all of these instances were replaced with asterisks. It made a new copy of the string and then stored that back into tweet here. The next line is going to do the exact same thing, but just for unhappy. And you can see unhappy has been replaced with a bunch of asterisks. And the last one, same thing, but just for sad. When we run that, we can see sad here and at the beginning have been replaced with asterisks, and then that new string has been stored back in tweet. So at the end, when we run this final print, it's going to print out there were however many bad words that we currently have in bad words, and the text bad words. Remember, we need to use the string function here because bad words is an integer and we can't add integers to strings. So this turns it into a string and then adds to this string and then print outputs it. Let's see that. We can take a look in the console. It says there were 7 bad words, which is correct based on this. And the final line is going to output what's currently in tweet, which is the version that's in lowercase and censored, as well as having the beginning and ending characters stripped. As we get further in the course, we'll see ways that we could improve this code using loops, so we could just simply have a list of bad words rather than writing a new line each time. But for now, using what we know, we have to add a new line. But this is still quite powerful for just the simple concepts we've covered so far. Let's head back to the slides. Okay, we're back, and I have a copy of the output shown here. One last thing I should mention about string methods is that there are many more helpful functions built into the string object. We'll cover more of them in the coming weeks, but I do recommend checking out the Python documentation for the string class. You can find a link here, and it details all of the methods you can use on strings. The last topic we're going to discuss in this video are docstrings. Docstrings provide a second way to document our code in addition to comments. Recall that comments are text that comes after a hash symbol and are ignored by Python. They provide a way to document our code for a human reader without changing how our code works. Docstrings provide the same functionality, but are a special kind of string literal that can be used to document modules, functions, methods, and classes. Docstrings take advantage of the fact that if we do not assign a string to a variable or pass it to a function, Python effectively is going to ignore that string and treat it like a comment. Docstrings are always surrounded by triple quotes. That's the double quote character repeated 3 times. Now, technically a single quote repeated 3 times would also work, but the PEP 8 style guides recommends using 3 double quote characters for any docstrings. So here's an example of a docstring comment. Note that unlike comments created with a hash symbol, docstring comments can span multiple lines. The important thing here is they have to start with 3 quotes, and those can be on the same line or the line above, and they have to end with 3 quotes, and those can be on the same line or the line after. So let's take a look at a quick example. And in this example, we're simply adding a docstring comment to the last string example we saw, which is example 1.10. In this case, we can see a docstring is being provided to provide a very long, detailed comment about what this program does. And this comment is ignored by Python. This is a great way to document your programs, and for each assignment, you should include a docstring at the top of the file detailing what the program does and who wrote it. That's all I have for you in this video. Strings are going to play a big role in many of the programs we see on this course, and that we'll be working on in assignments. So I highly recommend trying out some of these examples that we've shown. They should be on the learning management system so you can download them and play with them. The best way to learn programming is through practice and trying things out rather than memorization. So I highly encourage you to try things out for yourself in PyCharm or the Python console rather than just watching the lectures. Thank you for watching and have a great day.